Okay, so in our today's class, I wanted to talk about databases. All right, but before we start talking about that, I needed to set up a problem and to let you guys understand what's the issue over here. So first of all, here's going to be a simple example that you can probably relate to. We're going to design a class. We're going to create a data type for a very common problem. Like let's say we want to store data for students, right? So for each student, we maybe want to store a student ID, the name of the student, the CGPA of the student, the address of the student, and also perhaps the date of birth. Okay. So there are different type of data that we want in this data type or in this class. Now I can go ahead and write a Java program to do that. But usually, the way things are done in software engineering, we don't start with coding. We do some designing. And I haven't introduced this yet in this course, but here's a nice tool called UML class diagram. Let me write the name down. Okay, it's a software design tool. This is unified modeling language. So it's not tied to any particular implementation language. So it's not related to C++. This is not related to Java. This is some designing you can do on paper. What this helps though, like you can take these designs to some developer to communicate with them, or you can even take them to clients to talk to them. And these are easy to understand. And you'll get the feel. I mean, this is really easy stuff. So for example, when I say that I want to create a data type for student, I'll give it a name. Let's say I want to call this student, right? So in this box that we have three parts. The first part gives you the name of the data type, that's student, okay? And for student, we want to store a few things like the ID, name, CGPA, such and such. We can call them that those are my data members, and those are actually our attributes. So for example, I want to store the ID of a student, right? I can write the name and I can put it there. See, it says plus ID. I'll explain that plus sign in a bit, but then let me write a few more down. Let's say the name needs to be there, then the CGPA needs to be there. I will apply. Like as soon as I apply, you'd see all these names. And also, we want to store the address, and then maybe the phone number, okay, and also the date of birth. So just by looking at this diagram, you can readily understand that if you want to store the information of the student, you need to store information about all these attributes. We need to know the student's ID or store student's ID, the name, CGPA, address, phone, and date of birth. Right? Is this thing clear? So in a UML class diagram, we can have all the attributes or the data members listed. But when we talked about encapsulation in our class, this is something we stressed on, that all these data members need to be marked private so that no one gets to change them or access them in a way that we didn't allow them to. Do you remember private, public, those keywords? So this plus sign over here, this signifies that these are all public members. Anyone can access them, which is something we shouldn't do, right? We shouldn't let people or anyone to access these things directly, so they need to be marked private. So that's the distinction. Minus means private, plus means public. So I'm always clicking on the wrong thing. So these things, they have to be all private. I can't select multiple things, so I have to do it manually one at a time. Okay, so all these things are private. That's the first thing. Then for each of these data members, one key thing for us to understand is that we need to know what type of element is this, what type of variable is ID. What's that? Let's say integer. Okay, so that's a good start. I mean, this is not going to solve our problem because in our case, our ID is 13-digit long. You cannot fit 13-digit into a regular 4-byte integer. That's not possible. So this is probably not for Southeast University. This is for some institute where the student ID is, let's say, 7 or 8 digit long. Okay. For our case, we may choose a data type that's 64 bits long, maybe a long can hold that. Okay. But since you said ID is going to be integer, I'm just taking that. For name though, what should be the data type? String. So you can readily see that the way that we are assigning these things is a little bit different. How we write this is a little bit different. Because in Java, the way you declare a variable called name of string type, you'd have to write string space name, put a semicolon after that. That's how we write it. But over here we are writing -2 to signify private, then the name of the variable or the object, colon, and then the data type, either a class or a data type right in there. So for the rest of them, for example, CGPA can be a floating point number, and for precision we can say that this is going to be double. For address, this is going to be a string. For phone number, string. Well, if you want to bring in the plus or some dashes, if you want to write like that, a string perhaps. And date of birth. Yes, you can write the date in a string, but if you want to manage things, like if you want to get the month out of it, if you want to get the year out of it, a better data type in terms of Java is local date. Something that we discussed about in our last class, right? So for each of these things, see, now we have a student data type, and for each of these data members, we know the name of the data member as well as the type. So this is the syntax, but this is easy to understand. I mean, this syntax doesn't really belong to any particular language, although when we are picking particular classes, local date, it's a class of Java. But we still get a sense of idea that this is a data type that needs to be created or given by the library somehow. So again, the name of the data type is given, and the second box right in here gives us all the data members that are in this class. Okay. What about the third box? The third box actually lists out all the methods that you have for this class. So those are called the operations. The methods are called the operations. So over here, one crucial method is for a student object, you'd definitely want to know the ID. But over here, we have marked that as private. So you cannot know the ID of a student. So what we can do is we can, well, yeah, access that ID. So there should be a get ID method. Whenever you're talking about a method, what are the things that we need?
It should be public.
Well, yeah, method is public, it's given. A method actually has 1, 2, 3, 4 parts. The return type, what is the return type of the method, the name of the method, the parameter list, and what's the fourth part? The body of the method. What are the instructions that you need to execute in there? Okay. So let me just give you a quick example for those of you who couldn't follow. Let's say int add int ab. This is a very simple function. You just need to return a plus b. Right? That's the add method, right? So by saying that it has 4 parts, I mean it has a return type. There is a name of a method. This is the parameter list, so that's number 3. And over here there can be 1 or 100 statements that tells you what goes inside the body, right? So if you look at this getID method, I mean, you don't really get all these answers. You only get the answer that the name of the method is getID. We know one more thing, which is there is no parameter over here. The parameter list is empty. However, it's not telling us what we are going to return. What should we return when we ask for the ID? Integer, because that's the type of ID. So if you ask for getID, then that's what you get. Okay? And if I want to write for each of these things, actually this is something we need to get. For example, there should be a get name. I can ask a student, what's your name? What should I get as a return value? String. So there should be a method, get name, which is going to return a string. I can ask for get date of birth, and that's going to return a local date. Is this thing clear? So I'm not writing them all of them down because it's going to be too long, but just to give you a sample, let us create a bunch of them, like not all. So for example, get name is going to return a string for you. That's that. And also get date of birth, which is going to return a local date. So the accessor methods or the get methods, they're very simple to write. Return name, return date of birth. That's all, right? There could also be some set methods, and this is where you'd possibly understand the power of encapsulation. That once we give a student an ID, are we allowed to change the ID? No, you can't, right? When you go for admission in Southeast University, do they allow you to pick a number for your ID? Say you're given ID number 13, you can't say that I don't like this number 13. It's not your choice. It's just that you're student number 13, so your ID is 13, and it's just the way it is. So you can't really have a set method to change the ID. What about name? Would you want to change your name once you get admitted? Usually no, and more so these days. And previously we had a trend that girls usually when they get married, they change their last name. We had a trend like that, but I mean in most cases they don't even do that these days, so that's even not an option. So if you feel that you need to provide that feature that people may want to change their own name, yeah, there should be a set name method in there, but not for getID, not for sure, there shouldn't be. Set CGPA doesn't really make any sense. Let's say my CGPA is 1.29. I don't like this number, I'm just going to call set CGPA 4. That's not going to happen, right? CGPA needs to be calculated based on my performance, whatever I got in the different courses. So this is also out of the question. What we can do over here for address though, I mean, this is something we definitely need to change from time to time. Let's say when I got admitted, I was living in Bonani area, but for some reason I had to move out to, say, Uttara Lake City. So yeah, that can be an issue. So you have to provide this feature that says there should be a set address method that doesn't return anything, because I'm just only changing this thing. However, I need to allow for a parameter where I'm going to pass the new address as a string. So let's see how this looks like. Set address, what is it taking as a parameter? New address. What is new address? It's a string. Okay. And there is no return type, so there is no colon after that. It's not returning anything to you. And not everything is just get and set. All right. You may get a wrong idea like this, but I'm going to give you a good example over here. What you can do is you can get the age of a person. Okay, we don't have any age over here, do we? We have date of birth. Date of birth and the age, they're not the same thing. The age needs to be calculated based on today's date. Okay, It's a calculated value. It's not a stored value because it gets updated every time. So get age, let's say we are going to return the number of days for that person, or we can also use years. Okay, there can be months issues, so you can provide a fraction or a floating point number over here. So get age, or actually let me give a different name over here so that this is obvious. Calculate age. Calculate age calculates the person's age on today's date and returns the number of days as return value. Is this clear? Okay. So with that out of the way, like we have a student class where we see that there are a bunch of data members and a bunch of methods that can work on those data members. This is what we call a UML class diagram. Okay. And before you even write one line of code, you're supposed to analyze the problem that you're trying to solve and design these things. Okay. Programming becomes a lot easier with all these things documented properly, because the person that you need to develop the software for, if you're working in industry, you need to communicate with them, and then if there is a team working, like if you yourself is not the only person working, like you need to communicate with the other members of the team, and designs like this can help. And you can design a bunch of class diagrams and give the people tasks. You can distribute the task that you go and design this class, you go and design this class. There needs to be a common agreement how these things are working, and a class diagram pretty much shows that in a picture. I mean, this itself is not going to run, right? It's a diagram. There are some only boxes over here. It's not a program. So we need to understand that although there is a term language given with UML, Unified Modeling Language, it's not a really programming language. It's more like a drawing language where you draw a bunch of diagrams, and class diagram is one of them. You also have sequence diagram, you have use case diagrams. There are like 8 or 9 different sort of UML diagrams, and I'm only talking about UML class diagram here. When you go into your software engineering course, that's when you learn all about all those different type of UML class diagrams, why you need them, and all that. But this is a good practice to start thinking about stuff, about the design, and then writing the code. So let me start this project. We won't be able to finish it today, but it's going to be a good start anyways. I'm going to go ahead and call this database demo, although this is not going to be related to database right away, but we will build on it. So in this database demo, based on this diagram, whatever we got here, we can create a class out of it, right? Yeah, student class. Yeah. So in this student class, as you can see already, what we have is a ID name, CGPA address, and also we have the data type for each of them. Okay. So I can actually write these down. Int ID, string name. We have the address, we have the CGPA. What else? The phone number, and also date of birth. So once you list out all these things, for local date though, you need to import java.time.localDate. So we are importing that with alter insert, or you can alter enter rather, and you can also type it out by yourself. We talked about import before. Okay. So now about writing these things. I mean, it's a good practice to always write a constructor. Okay, so for now, I mean, the default constructor, it stays blank. There's nothing there. But you can also add a custom constructor, like if you pass the ID and name, can we make a student object out of it? I'm not supplying the other parameters, but I'm just giving these two. So we can write it as this.id equal to ID, this.name equal to name. We can write constructors like this, and NetBeans actually gives you this feature that you can, excuse me, you can get it auto-generated. If you press Alter Insert in NetBeans, brings up this menu that you can auto-generate it based on the items that you need in your constructor. Let's say I need all of them. I don't have to write this constructor by myself. I just say generate and it generates it for me. Okay. And also you can see that there are a lot of get methods, right? We need to be able to access these values. We don't want them to change, but we want to access all of them. I can go ahead and write that myself. Like I can go write public int get ID. What do we write? Return ID, right? This is a very simple method. It has a fixed pattern. All these parameters, all these attributes, how you want to write methods for them. So the idea is that you can write them, but I mean, what's the point? We are using an integrated development tool. So hold down Alter, press Insert, bring up Getter. So all these things that you want to write, you can select all of them. And here's a very nice feature, says encapsulate fields. So let me show you that we haven't written private or public anywhere, right? In this data members. But when you do Alter Insert and ask for the getter methods, you can just put a check mark against encapsulate fields. See, it has written all these methods for us. And also, since we have marked it as encapsulate field, everything is private. So this is a bit of a production tip that you don't have to write all these things by yourself. You can have NetBeans write it for you. And the same thing goes for the setter methods. The methods that you want to allow, like the attributes that can change. I don't want the address, well, yeah, I do want to change the address, but not the CGPA, date of birth, ID, name. The phone I want to change. I may go for a different phone number. I may go and live in a different address. Okay. So how do we do this? Put a check mark against address, put a check mark against phone, and encapsulate field, you can put a check mark here, but it doesn't make any difference because we have already encapsulated it. See, all these things are automatically written for us. Is this clear? Okay, so calculate age. This is something not done for us, right? I will fill it in a bit. See, how do we calculate the age? Right, we need to know today's date. We already know the date of birth, right? What's today's date? Let's say we call this today's date equal to local date dot now. And we know the date of birth, right? So let's try this. Let's see what are the methods that are available to us. There was one method. Let's see. Okay, got it. Between local date and today's date. So there is another class called duration. Okay, duration dot between, and you can give today's date and date of birth. Okay, these two parameters, you can put them in, and that duration is what we want to return. We want to find out what's the duration between these two dates. So what are we returning? The duration, right? So we are returning this. we return the duration between today's date and the date of birth. Okay?
So what will it return? Year or day?
Duration itself has all these things. You can get it as the days, you can get it as hours. Okay? So there are different choices for you. So let me just give you a demo of this thing, how we can create a student data type and set all this information. Let's say we want to create a student, right? So we can say student equal to new student, and here we can pass all these attributes. Okay, let me make my life a little bit easier because there are too many things that we can pass over here. So what I want to do, since I want to test the age, alright, so we have a constructor where we can pass the ID of a student, the name of a student, and the date of birth. Is this clear? Alright, let us get started. Okay, I need a male volunteer, any student. I can give an ID 1 and no volunteer?
Rasmus.
Nazmul, okay. With a Z or a J?
J.
You know what I'm going to ask, right? Yeah, that's why I needed the volunteer. And that's why I didn't ask for a girl. They won't tell.
1996.
1996, okay. And what's the month?
December. 28.
28. Okay, that also tells you guys when he's going to give a treat. You have to wait for a few months. Okay, so December 28th, right? Now we can call student.getAge and see, or calculate age rather. Calculate age to see if it properly calculated your age or not, right? No, it didn't work. Temporal limit, I thought time is a temporal limit. Oh, I think. Can't go for seconds, I guess. No, that's in and out. Just a bit. Did I do it right? It's okay, alright. Today's date is there, date of birth is there. Let me get some help. Okay, not duration between. That's my fault. So we should have another 20 years between. I need to import that.
You don't type tables.
Yeah, we'll fix that as well.
Once.
Yeah, how many days? So got the wrong import, I guess. Okay, now it works. So we need the java.time.temporal chrono unit, and we also need to get the static import. And now we have this, we can have the days between a certain date. So now when we run this thing, we get -7508 because we did it the other way around. So we have to put the date of birth first. This is the older date. And now today's date goes here, and that tells us that Najmul is today 7,500 or 8 days old. Yeah, let's do that. 365. Is that right? All right. So long as Najmul says that he's 20 and a half years old, I think this is okay. Now, say we created a student object, okay, and you can see that there are a lot of attributes that we can save for this particular data type, and that's something we captured in our class diagram. And from here, we could write that class easily. Once we have all these things in front of us, it's easy to write. However, this YAML class diagram, what it lacks in is actually the code or the instructions that you have to write for the operations. Because I told this thing in this YAML class diagram that I need a method that calculates the age. Okay? And over here I said int, but it should be really long because, well, the number can be pretty big. So we have a calculate age method, but we didn't say exactly what are the instructions that you need to write in there. And I failed myself writing the calculate age method. I had to take some help from Stack Overflow. But then now this is working. So we can write a class based on this design. This is the idea. Now let's talk about persistence. Let's talk about how we can save this data into a file, for example. Right? We want to write all this information like the ID of the student, the name of the student, the date of birth, what else? The address, the phone number, and CGPA. All these things have to be written down somewhere. Okay. So what we can do here, if you want to print this out, let's say I can calculate this age, right? That's something over here. I can call that method and I can print it. But what if I want to print this student object? Just like that. Can we do this? It doesn't give us anything meaningful. And I would really want to know the ID, I would want to know the name, the date of birth and all these things, but I don't get to because none of this is here. What you can do to solve this problem is give a string representation back. if you tell Java that the way to represent this object as a string is like this, that return the name, okay, then what's going to happen when you run this code? It's actually going to print Najmul. So that's quite interesting. See, I got a data member, that's name, and in my toString I'm returning that, and Java understands that when you're calling system.out.println and you pass an object, if you don't tell me anything, I'm going to call toString by myself to know what this object should be printed out as. Okay, but if you name this method as something else, to my string, for example, you can call it whatever you want, right? But that's not going to help because Java only knows toString. So it has a very specific syntax, public string toString. If you have a method like that, then you can actually print out all the details that you want. Now, for example, I want to print the ID and the name. We can write ID plus name, right? So then our ID will be printed, and right after that we'll have that name. So you may want to put a separator over here. First the ID, then the name, and anything that follows. So let us build this up. Date of birth. Okay, so now when I print the student, I actually get all the details, or at least the parts that are given to me. Is this clear? So toString is a very convenient method that you'd want to write for each and every class that you create, because once you write that, you can call other methods like system.out.println to simply print that object. Is this clear how we are going to write this toString method? So you can select which members you want to print, and the other ones you can simply ignore. Now,
can we write a function ourselves like this?
yes, you can write the function by yourself like this, but since we are using an ID like NetBeans, you can also use the alter insert key combination to have the toString written out just by clicking a few things. What are the things that you want to print? Say I want to print all of that. Just say generate, and let me print this for you. See, student, this is a student object.
So I know that this function is called automatically.
Yes.
So can we make a function that called automatically like this?
Yes and no. You see, there is a particular reason why Java knows that if you define something as toString, it will be called. There is a particular reason for that, and I haven't covered that topic yet. This is called inheritance. This student class is actually inherited from a class in Java called object, and this toString method is defined there. So hold your question for now. When I introduce this inheritance concept, I'll come back and explain this further, because right now it probably wouldn't make much sense to most of my students. So yeah, I mean, if you write a method called toString, which returns a string, and there's a public method, it can pretty much return anything, any string representation. And I got this thing generated by NetBeans itself, so I didn't have to write it, although I could if I wanted to. All the members that I want to print, I could write them out, and it prints them just like that. So you can see that date of birth is properly printed, there is no phone number given, there is no address given, and the CGPA by default it's 0.0. Is this right? Okay, so now we can create a bunch of other student objects, and we can simply print them out. Right? It's not a big deal. And you can also imagine that we can create an array list of students. Call this student list equal to new array list, right? And now the student that we just created, we can insert that into that array list. Can we do that? Right? So we can do this. Is this clear? But if you can do that, then you can also take this part and put it right here. because it's creating a new student object and then it's inserting that into the student array list. And if I want to print all the students that I have in this array list, can we write code for that? With enhanced for loop for student called student in student list for each of them. So we can print them. We know this much, right? Is this clear? So based on this line, can we create a bunch of other students? Say with different names, of course. 1, 2, 3, 4, 5. Yeah. I'll change all the names here. Okay, so that's that, and just so this is not Nazmul anymore. So you get the idea. Like I got a bunch of students here in the students list, and if I run this program now, I can see all of them, and we got different names, different IDs, and some of them have common birth dates, some of them don't. It doesn't really matter. So we can print them on screen. Now if I ask you, can you write them out in a file? We know how to do that, right? Instead of printing them like this, we could also write random access file output equal to new file. And let's give it a name, students.txt file. We want to write to it, so it should be read-write mode. Okay. And now here's a problem that we don't have it imported, and then also there is a problem with try catch because there can be file not found exception. There can also be IO exception. So those two things we need to account for. Write bytes, yeah. I'll change that. Let me just get this thing done. Yes. Let me just write this and I'll change that for you. So we could write it like this, and we can throw in our own instructions. Like you can put system.out.println and fix that. But you can also have it auto-generated. Okay, so let me show you that part. So let's say I didn't write all these lines by myself. What if I want NetBeans to auto-generate these for me? You can just click on this balloon or hold down Alt or Enter. You see there are some options. If you add throws clause, what happens, it adds that throws file not found exception, IO exception, all that into the method name. So whenever this method is called, it's the responsibility of the method caller to handle all these things. You can do that. Or alternatively, you can surround this statement with try catch, so it only surrounds this particular statement where an IO exception can occur or a file not found exception can occur. It can create that block for you. Or if you say that surround block with try catch, it's going to cover the whole thing, like this whole block. It puts it under try catch, which is something that you don't want, because there is no possibility of an exception when you create this array list and insert some students in there. So for our case, I mean, we're probably going to go with surround statement with try catch, and once we do that, we can put this thing inside that block, and the part that we have manually written, I can get rid of that. So it's pretty much the same thing, except for when it does it by itself, it will log things into a particular location. Logger is a very useful tool. When you're running any application, sometimes if some application crashes, it will often report that I've saved all these things in a log file. And you can actually go back and open that log file and see what happened. It's a sort of a crash report. So it's a very useful tool to track when your software performed something that was supposed not to do, to catch the bugs. And that's the concept of logger. And if you don't understand logger, that's fine for now. If you want, you can just replace this line with your own system.out.println. But as you get matured into software engineering, you'd find that often when you deploy something, you'd want to keep all the logs of what's happening. It's not just a single printout. You have to track all the things that led up to this point. So that's the concept. What's that?
From sometime show problem for this.
Yeah, it can show problems, but then you'd have to report a lot of things. Those of you who have used Ubuntu, like if some program crashes, it asks you to send a bug report to the Ubuntu team so that they can track. Right? What are the information that gets sent away? Like it tells all the information about the hardware that you have installed, tells you about the state of the operating system, what's in there, and then also what had happened with that application. Yeah, Windows probably does the same thing. I'm not using Windows for a long time, that's why you can't comment, but well, it's a very basic requirement, really. So instead of printing it out on the console, right now we are printing it out on console, right? And this is something we don't want to do, since we have the file already. Why not write it to the file instead, and then write them in each and every new line in this way. So over here, there can be one more exception, so we can add a catch clause. It will automatically add this exception. So if you are using NetBeans or any other IDE for that matter, the good ones, they help you write these things so you don't have to waste time on. But you should have a clear understanding of what's happening, like why do we need this try catch and all that. Okay, so for now, if you run this program, you'd see that it doesn't print out anything at all right now, but it actually saves everything to our NetBeans projects. This is summer 2017 Java, and in this database demo, there is a students.txt file where I have all my student information written out. Just like that. Is this thing clear? Okay. Now, if I ask you to find out all these students that were born before 1950, is it going to be an easy task? Yeah, just because there are only a few students, like 4 or 5 students, it's easy to track. There are only 2 students who were born before 1950. Okay? But think about a scenario where you have 10,000 students in your text file. How do you find that out? Using the for loop. So you'd have to go through each and everything, and you'd have to extract this part. Because every time you read a line, you're going to get all the information that you probably don't need. You also get the student ID, student name, and all that. But maybe I just want to print the student ID and the date of birth for all the students who were born before 1950. Can't really do that easily. I mean, if it were given in Excel or a spreadsheet, maybe that would be easier because that has a sense of columns. You'd have a column for ID, you'd have another column for name, you'd have another column for date of birth. It's easy to track that way. If you're given a tabular view, it's easy to see. But in a plain text view, is it a really easy task to find this thing? It's not really. Okay. So let us complicate matters a little more. So we can save our information into a file. We know how to save. We know something about persistence. And this is the scenario right now, based on our knowledge. But we are running into a problem that once you save things in a file, it's not as easy to find if it were saved in a table, for example. Okay? A table is a better view for searching this sort of information. Now, think about a real-life scenario. Let's say that we have a lot of terminals from where there are admission officers, prospective students. They come to those admission officers, and if they want to get admitted to Southeast University, those admission officers, they are going to create a student account and save that information into our file. Okay. Let's say in our admission office, I got 5 admission officers working. So are we going to provide them with only one computer? No, that doesn't make sense, right? So I'm talking to a student, and when I need to admit that student, I need to go and work on one computer, and if someone else is blocking that computer, it's not going to help. So I need to give specific access, like terminals to each and every one. So from those 5 computers, if you're all trying to write to the same file, is that going to work? Can you share a file with your friend, and you and your friend, you're going to write to the file at the same time? Can you do that?
Yes, sir.
How? Now, here's a problem. I mean, there are a few solutions. One is if you're using some tool called Google Docs, for example, then not only let's say 100 people can access the same file. They can all write to that file at the same time. But that's a totally different service. Okay? If you're thinking about a file sharing system like Dropbox, how many of you have used Dropbox before? Okay, so some of us, we do have idea about Dropbox. We can share some folder that we have on our Dropbox with some friends, or maybe we can open it publicly. Now, when we do that, when we share a folder, if we have a copy that we are working on and someone else is working on the same file, what's going to happen? Like, you don't have to have a friend. Let's say you're working from home. You work on a file, you save that, but if you have that file open, you come to office or to some other place where you download that file and you work and save it again. Dropbox is not going to be able to understand which copy it's going to keep and which one has to discard. So some of you may have experienced this, that they will create a separate file in the same name, writing conflicted copy from this computer. So it will keep the copies, but in separate files. Because if 2 of you have the files open in 2 different ends, and if you're writing, it doesn't update your view. If your friend has his copy of your file, whatever he's writing, it doesn't update your view, what you see in your computer. So when you save and your friends save as well, so they're 2 different things, because you can write 2 different lines. So there is no easy solution to that. However, over here we really need that, because they're all writing to the same file. They're all reading from the same file. So this is a big problem, because if you think that your registration system will, whatever your courses you're selecting through SETproof advising, they're all going to be written to a same file. It's not going to work, because it's only going to create a bottleneck right in there. When one student is registering, no one else can register, log into that system, because he or she has total control of the registration file. Once that's done, in comes the next student. Okay, so we cannot allow multiple students to log into the system or get the service at the same time. Now you may say that, I mean, this is the current scenario over here, which is not. I mean, what happens really is that there are too many students that we cannot support. They log in at the same time and they try to register, so the system is not responsive anymore. But that's a separate issue. But if you log in like 10 students at the same time, they can do their registration with no problem at all. Okay? That's the real scenario. So with a file structure, it wouldn't be possible to even allow 10 students to do their to register into the system or to get admitted like this. So this is a problem with file-based saving. So what are the problems that we are addressing right now? It's difficult to search. Okay, it doesn't provide multiple people access to the same resource at the same time. And also, I mean, I haven't talked about it, it's also a security concern. You cannot really control what sort of access you want to give to people. Maybe you want to give read access to some certain people. If you want to give write access to certain people, you cannot really control that in an easy way. So here comes database management system that really addresses all these issues. In a database management system, it's the job of the management system. For example, there can be a lot of database management systems. Just to give you some names, like we heard about Oracle, right? Oracle is a database management system. You can create your own databases where you will store data in a tabular format. And the same thing you can do with MySQL, with MariaDB, or you can also have Microsoft SQL. There are many different database management systems. Okay. In this course, what we are going to do, we're going to create databases with MySQL, because that's freely available. You can download a community edition, install it on your computer, and access that. There are also many other free database management systems. Some popular ones can be PostgreSQL. You can also get MariaDB, which is pretty much the same as MySQL. But if you're talking about Microsoft SQL, or if you're talking about Oracle, none of them are free. That doesn't mean that they're bad. Actually, they're pretty good. Both of them are pretty good. But the thing is, you'd have to buy license for them, or get pirated copies, which I cannot support. Okay, so that's the reason I can't really show you how to work with Oracle over here, or Microsoft SQL. That said, we are actually going to work with a language in this course called SQL, Structured Query Language. Okay, it's a sort of a programming language, something new, but this SQL is the same for all these database management systems that I talked about. You can write exactly the same query to get your answer. You can write exactly the same command to insert some data into your database. They're pretty much the same thing with some minor modifications. So it doesn't mean that at the end of the course, if you decide that I want to work with Oracle, not with MySQL, you can easily make that switch, because most of the things will be the same. That's the point I want to make. Okay? So let's have a quick look at what we have done over here. We have a student record that has a bunch of attributes. I think it's easier seen over here. So we want to create a database and want to store only those information into the database. Okay. So in this class, I'm not going to go into details, but I'm going to give you a brief demo of what's really going to happen when you create that database. So to connect to MySQL, you'd have to download, install, and run the server. That's the requirement. So just look for MySQL download. It will take you to community downloads. You can download the version that's appropriate for your operating system and the architecture of it, either 32-bit or 64-bit. So for example, if you want to download the community server, you just go to this, and then it asks for specifics about OS and whatnot. Right, so you can select the operating system, right? And then install it on your system and then run it. Now once the server is running, you can connect to that server using a terminal like this. You can run some commands and work like that. Or there are tools like Microsoft MySQL Workbench. I don't know if this is installed. Yes, it is, thankfully. So with some graphical tools like MySQL Workbench, you can also connect to database. Let me just show you what this is. You can, I don't even remember what it is. Okay, so I can actually log into the system and run queries like this. It's from a previous semester. Shows you tables, exactly how things are. This is a graphical view. Okay, so for those of you who don't really want to work with terminals, you can install tools, extra tools like MySQL Workbench. But if you want to get your hands dirty, and this is probably the better way of learning things, you can write your commands through a terminal. Okay. So the first thing you'd want to do is to run MySQL to connect to a database. I'm doing it as the root user. Root means the admin user. And I got MySQL installed on this PC, so I'm just writing it like this. If I had MySQL in another PC somewhere else, I'd have to give the host name, the IP address of that. Okay, so I know the password for this one, so I got in. We can create our database. Let's call this, okay, let me see how many databases we got. We got a lot of them. Okay, so what I want to do, I want to create a database. I want to call this StudentDB, because this is going to hold information about students, right? And related information. So I do that. And inside a database, there can be a lot of tables. So there are some very basic commands, and these are all SQL commands, like create database, name of the database, and then a semicolon. This is a query in SQL. This is a language, all right? So it has a specific syntax. However, for SQL, the good thing is it's very close to English. It's very natural. For example, if I want to create a table now, create table, what's the name of the table? I want to create a student table. It's as simple as that. Yes, it is case sensitive. If you're working in Linux, it is very much case sensitive. So it's going to make a difference whether you have a table called student or a student with an uppercase S. Yes, they're going to be different. And then you put a semicolon, right? So we want to create a table for a student. And you can imagine that if you want to store information for a student in a tabular view, I want to have separate columns. There should be a ID column, another name column, CGPA column, phone number column, and so on. Different columns. And each of these student records, they should come in rows, one row after another, right? Just to show you, if you didn't get the picture, this is a spreadsheet. You may have seen Microsoft Excel. It's pretty much the same thing with a little bit less features, but this is free. So what we can have here, we can have different column names, ID, name, date of birth, like this, and some other columns, and then you can fill it out with the proper information. So for example, we had Najmul's record, 1996, December 28th. So that's the date, and you can throw it in just like that. Okay, so for other students' records, how are we going to put that in? One row at a time. And those are all our records, right? We are pretty familiar with this view, aren't we? So tables are like that. When you want to create a table, create table, table name, you just say this, but based on this information, it's not going to be able to work. And also, I made a mistake. When I created this database, there can be 10 other databases over here. Which one do we want to use? We didn't say anything. When we work in Excel or Word or any software, we have to open a file first, right? We didn't do that. We created only something, but we didn't use it. So here's a very important command. I should have done this. I just forgot to do it. You have to tell which database you want to use. Okay, so use student DB. Now the previous command. The good thing about the MySQL terminal, you can press up and down to access your previous commands. So create table student. No, you can't. Why? The table should have at least one column. Okay? So this is how you describe this. In bracket, you give the name of the column. I want an ID column, a name column, a date of birth column. I'm just writing it in short. Date of birth. So I need these three columns. Okay? Let's try to create that. No, still can't, because see, we got an error right in here. You're telling me that I need these three columns, but you didn't tell me what type of data you want to store in there. I want integer ID, I want string name, I want local date. Okay? So if you have the notion of Java, then you'd probably want to write it in this form. Okay? But this is not going to work because the data types, they vary from language to language. A very simple example can be, in Java we have Boolean, B-O-O-L-E-A-N, right? Boolean data type. What's the equivalent in C++? Bool, B-O-O-L. They're doing the same thing, but they're written in a slightly different way. Okay? So you have to understand that this is the same case in SQL as well, that we have the data type. It's just that they're called something different, and you have to write them in a slightly different way. The syntax for Java, C, and C++ is you write the data type first, and then the variable name. In SQL, the syntax is give the name of the column first, then the data type. So instead of int ID, you write ID space int. Instead of name, string name, you write name and then string. However, you can't write string because string is not a data type in SQL. We got something called varchar. It says variable character, and you have to put an upper limit over here. What's going to be the maximum length of a name? If it's anything less than that, then that's fine. But it cannot be longer than that. Let's say none of our names will be more than 60 characters long, so that's an upper bound. Okay? And if you put any name that's longer than that, it's simply going to truncate, leave out all the extra characters after that. So this is varchar. The difference between string and varchar is that in string there is no limit. In database though, you cannot go limitless because you're going to store data physically. So you have to put a limit to that. So 60 is that limit. And then local date is not a data type in MySQL. This is called date. So the data type and then that. So now it says query OK. And just to see if the database was created right, you can actually the table was created right, you can describe that. DESC says describe. You can describe the student, and like you see that we have three columns and they're called fields. We have ID, name and date of birth. ID is integer, name that's varchar, and date of birth that's date. Okay, we need to insert data into the database. We can simply write insert into table name student. What are the values that we want to insert? Let's say ID number 1, name is Nazmul, and the date of birth is 2006, 1996, 12 and 28. So that's the record that I want to insert into this database. I write it out, hit enter, and that's gone. Now if I want to insert a second record, okay, that's another example. So we have now two records in here. Is this clear? Okay. And if I want to select all these things, if I want to view what are the student records inserted, I can do that. See, this is quite easy to use. If I exit out of this database, I can come back to it again. Let me connect to the database again, MySQL -u, then the username, which is the admin username. I'm logging in. I'm going to use the student DB. I can now say select star from student again, and my data is not lost, it's still there, and I can access that. And the fun thing, I'm not going to do this in today's class. In the next class, what we're going to do, I will give you access, all of you access, to the same database. So you can log into this database from your computer, not this one. You can log in from your end, and I would ask you guys to insert data into this table. And you can do it simultaneously. So if one person is entering data, that doesn't mean the other ones can't. You can all insert the data from here at the same time. You can go and refresh and see what data has been stored. You can do all of that. So we'll get a feel of that thing in our next class. And then we will connect this thing to our Java application. So for example, we will create a form in JavaFX where we'll have student ID, student name, date of birth through a date picker, for example. We'll have all of that. Then when we hit the save button, it's actually that form is going to get connected to our database and save data there. Okay. So that's really the essence of this course. I mean, this course is not about databases. But I wanted to introduce databases to you because a lot of real-life applications that you're going to develop will have some database components. So you need to be able to communicate with databases to insert data or also to retrieve data. Is this clear? I mean, that's the direction that we are heading to. But before we come to the next class, what I want each of you to do is install MySQL Server at home and at least do this part. Create a database like the student DB, create a table, insert a bunch of records. Right? Please do that part at least so that I know that you can try and replicate these things at home. The rest is not that difficult.
So is it possible to run this code?
Yes. Actually, what happens in Windows when you install MySQL, what I've seen in other students' computer, that you get something called a MySQL terminal. So you can open it from your menu. There will be a terminal that's only for MySQL. So you can do that.